Hi everyone, in this video we are going to solve this question. The name of the question is Beautiful Towers 1. This question was recently asked in a Leetcode contest. Okay, so what we have in the question, you are given a zero index array called max heights of n integers. You are tasked with building n tower in the coordinate line. The ith tower is built at the coordinate I and has a height of the heights I. A configuration of tower is beautiful if the following condition hold. The height I should be in the range of greater than equal to 1 and less than equal to the max heights, and height array should be a mountain array. So what is the mountain array? Array height is a mountain array if there exists an index I such that for all j which are greater than 0 and less than I, height j minus 1 is greater than equal to height j, and for all k which are greater than equal to I and less than n minus 1, height k plus 1 is less than equal to heights k. Return the maximum possible sum of the heights of a beautiful configuration tower. Okay, so what we have in the question, we are given an array having some values. This array's name is max heights. Out of this array we have to create another array called height array, where the value of the each element will be lies in the range 1 will be greater than equal to 1 and less than equal to the value present at the max height at the ith index. Max height ith index, it should be less than equal to x. Okay, and the another condition is that it should form a mountain like a structure. Suppose this is our peak element. All the values which are on the right hand side of this peak value should be in a downward direction or equal direction. There should not be something like upward graph. Okay, so this is the right hand side of a mountain graph, and this can be also a right hand side of a mountain graph. So let me first tell you what are the different ways in which we can form a mountain graph. This graph is also a mountain graph, where suppose this is our peak element. All the element which are present on the right hand side of this peak element are what I say less than or equal to the peak element, as well as the values present at the next index. Suppose this is k and this is the k plus 1. The k is equal to the k plus 1. It follows the condition. It is either it can be equal or it can be greater than k plus 1. Similarly, on the left hand side, all the values should be less than I, as well as the value present at the jth index should be greater than the value present at the j minus 1, greater than or equal to j minus 1. Okay, so this is the one kind of the graph. The another kind of the graph is this other can be this way, another can be this way, where this is the peak element and here this is the peak element. Another can be this and this. Here this is our peak element I, and all the values which are on the left hand side are less than the I, and the value present at particular j index is greater than j minus 1, greater than or equal to j minus 1. Similarly, the value present at the right hand side of the peak element have the value lesser than the peak element, as well as value present at a particular k index have value greater than equal to the k plus 1. Okay, so now that you understand what is a peak array, peak element, and what is a mountain array, let's just solve our question. So we in the question it is given that we are having this element, this max max height array, and we have to create this array, height array, and this should be of mountain, and out of all the mountain array we have to return the sum of that mountain array that has the max sum. Okay, so how would I know whether selecting a particular element as in peak array will give me the maximum sum of a mountain array? How? I don't know. So what I can say, I can check for every element in the max side. I can check for every element in the max side. Can I take this element as a peak element? Okay, if I take this element as a peak element, I will try to form a mountain array out of it. All the values present on the left hand side should be less than the peak element, and the condition j is greater than equal to j minus 1, and the values present on the right hand side should be less than the peak element, and the condition k is greater than equal to k plus 1. These two conditions should hold. Okay, so I will try to make the mountain array, and also I will try to create mountain array such that I can get the maximum sum out of it. Okay, so the second point may be not clear right now. I will try to explain later. Let me just give you a dry run of what I'm thinking right now. So suppose this is our example. Okay, this is one of our example. Okay, what I'm saying is that I will check for each element. Can I make this element as a peak element? And if I take this element as peak element, can I make a mountain array out of it? And I will try to make a mountain array that give the maximum sum when I chose that particular peak element. Okay, so suppose in the actual question we will check for the each value, but for the dry run purpose I'm taking only the one value. Just for the better understanding, I'm taking the 9. Suppose I say this is our peak element. Okay, now on the right hand side, what kind of the structure I want a downward or equal structure. Okay, downward or equal, or it should be either a downward, it should be a equal. Okay, so I will check the values that is present on the right hand direction of the 9, whether this element is greater than equal to 9. There can be either this value can be equal to 9, or this value can be less than or greater than 9, but in this case 2 is obviously less than 9. So can I say I can add 2 in our mountain graph, and is it forming a mountain like a structure? Yes. Is it? Yeah, it is forming a mountain like structure because it is in a downward direction. Now for this 7, can I add this in my mountain array? To add this 7 in the array, I have to check it with its next. Okay, so if I have to add 7 in my array, I have to modify it. What values I can write in the replacement of the 7? I can write anything from the 1 to 7, but if I write anything which is above 2, like suppose I took 5, is it will lie somewhere here. Is it forming a mountain like structure? No, it is not forming a mountain like structure. If I chose 3, is it forming a mountain like structure? No, it is not. But if I replace this 7 with the 1, it should be like this. Is it forming a mountain like structure? Yes, obviously it is forming a mountain like structure. So I can say that I can transform 7 to 1, but is it giving me the maximum sum? Is it giving? No. I have a possibility of transforming the 7 from anything 1 to 7. So can I say I can convert this 7 to the number which is in the previous to the 7 to get the maximum out of it? because we want to maximize the sum. So can I transform 7 to 2? Yes, obviously this will give a much higher sum than compared to 9 plus 2 plus 1 if I chose it as the 1. Okay, so right hand side is sorted. Now now we have to check for the left hand side, the values which are present on the left hand side of our peak element. We are moving in this direction, okay, in this direction, right from the peak element to the 0th index. So the value present at before the 9 is 3. We have to check whether 3 is either greater than or equal to or less than 9 in our case. Not in our case, obviously the 3 is always less than 9. So I can say I can add 3 here. 3 is forming a mountain like structure. Now we have 5. To add 5 in this thing, can I directly add 5 here? No, because 5 will lie somewhat here and it is not forming a mountain like structure. So again I have to transform the 5, or I have to convert 5 between the range 1 to 5, where 1 and 5 are inclusive. So what values I can choose? I can have convert 5 to 4, anything 5, 1, 2, 3. So if I convert 5 as 4, will it form a mountain like structure? No, it will not form a mountain like structure. If I convert 5 as either 2, will it form a mountain like structure? Yes, it is forming a mountain like structure, but we are not getting the maximum out of it. In order to get maximum out of it, we have to convert 5 into the next element of it. Just if 5 is greater than the next element, we have to convert 5 into the next, that is the value present at the next index, that is a 3. Again we have the value 6. We have to compare 6 with this 3. So can I add directly 6 here? No, because it will form a graph like structure this like this. No, I cannot directly add 6 here, so I need to transform 6 into somewhere in the range 1 to 6. This is not okay, somewhere in the range 1 to 6. So what values I can check? I can make it as 1, 2, 3, 4, 5, 6. Again I cannot check for the 4, 5, 6 because it will not create a mountain like structure. I also cannot pick values like 1, 2 because it will form a mountain like structure, but I will not get the maximum out of it. So I will take only the value 3. Okay, so this is what our final answer is looking when we take 9 as a peak element. There will be another another array when I take 2 as a peak element, another array when I take 7 as a peak element, another array when I take 6 peak element, and 5 as a peak element. So there will be different arrays. Out of all these mountain array, I have to return the sum of that array which is having the maximum sum. So the sum of this array is that nothing but 3 plus 3 is 9, 9 plus 9 18, 18 plus 4 is 22. Luckily in our case this is the answer, but in the code we have to also check for the each element. So let me just show you the code. I'm taking a answer variable as 0 initially and is storing the max height size, iterating over the max height array, taking the sum as the peak element right now, and next and previous are denoting the next element of the array and the previous element of the mountain array. For the right hand side, this will be the previous to this element. So this element will be comparing its value with the previous of the mountain array, and for this value on the left hand side of the peak element, this value will be comparing to the next element of the mountain array. So initially both the next and previous will be the peak element. Now here I am iterating in the leftward direction from I minus 1 till j is greater than equal to 0. If the value present at the jth index in the max height is greater than equal to the next, then obviously I have to No, if this value, oh sorry, this value is greater than the previous value, then I can simply add it to answer. If this value is less than to the next value, then I have to transform it. For transform, I know that I know the next value will be the max side. Similarly, here in the right hand side, I'm doing the same kind of the operation. In the right hand direction, I am checking from the for every index I plus 1 to the n. I'm comparing the value present at the kth index with its previous. The value present at the kth index, this should be less than the this k sorry k minus 1. This should be in a downward direction, downward or equal direction. So if the value present at the kth index is greater than equal to previous, then sum plus equal to previous, else value will be the change. And after performing this operation, when I check for the both the side, left hand side and the right hand side, I will simply find the maximum sum as the answer and return the answer as an array answer. So as you can see, this is getting accepted, and when I try to submit this question, it is showing the accepted. So in the contest we have two variation of this question, beautiful tower 1 and the beautiful tower 2. In the next question, it will be a slightly tougher version. There will be more tight constraint range. So let's try to solve this question also, but in a later video. Okay, thank you.